Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to address the important question, is ChatGPT better than me? So we just did a video on the small angle formulae, and now we're going to ask ChatGPT the same question and see if what are the small angle formulae and how do we prove them. We're going to see what it says and see how it compares to the video we just did. The small angle formulae are approximations used in trig when the angle theta is very small. For small angles, the trig functions can be approximated as follows. Sine theta equals theta, yeah. Cos theta is 1 minus theta squared of 2, correct. And it includes tan theta, which is a good addition. These approximations are derived using the Taylor series of the trig functions around theta equals 0. Completely right. That is impressive. The higher order terms like theta cubed over 6, yes, and beyond become negligible. That is exactly right. So 6, of course, is 3 factorial. Very good. And then the Taylor series for cos theta. For small theta, higher order terms like theta 4 over 24. 24 is 4 factorial. Beyond become negligible. I mean, the bigger the power of theta, the smaller they become when theta is small. So for instance, I mean, we said this in our own video, but if theta was 1 over 10, then theta squared is 100th, but theta to the power 4 is 1 over 10,000. And then tan theta is sine over cos, so we just put in... Well, it's interesting, isn't it? Because we're putting in theta over 1. So there's something a bit funny here. We're not putting in theta over 1 minus theta squared over 2, because of course if theta is really small then cos theta is approximately 1, because we are neglecting theta squared over 2 as well. And a really precise teacher would have mentioned that in explaining how tan was derived. Geometric intuition. Theta is the angle in radians subtended at the centre, so the arc length of the sector is theta, yes. For small theta, the arc length is nearly equal to the length of the perpendicular from the circle to the x-axis, which is the tangent to the circle. Yeah. Yeah. I mean, that's basically right. So that was basically the geometric argument we gave, which is as theta gets small, the arc becomes close to the kind of the straight line in the appropriate triangle. Okay. These approximations are found in physics, engineering, and mathematics, and calculations involving small angles. That is correct. As theta tends to 0, these lengths converge. Yeah, I agree with that. So I think geometric intuition optional. Yeah, it is optional. Everything's optional. I mean, okay. I suppose, what do I think about, is the geometric intuition optional? Yeah, I think we do have a choice about whether we come from the infinite series point of view or whether we come from the geometric point of view. But actually my instinct would be they're both valid, but I would say the geometric intuition is actually more fundamental. So I would question the use of the word optional in brackets. I mean, in a sense, everything's optional, but I actually think... I wouldn't go so far as to say the geometric intuition comes first, but I think it is a bit more fundamental, and I think it's available to people earlier in their mathematical education. So I actually question that word, but, you know, that's all interesting. So I think this was a really useful exercise, and I'll be doing a lot more of this.